Okay, so we have to do part 5 today. 13.2 we were doing. The question number 5, a vessel is in the form of an inverted cone. Its height is 8 centimeters. This is a cone. Its height is, this is its height. So its height is this one. Okay, height is given and radius of the cone is given. 8 centimeters is its height and the radius of its top is 5 centimeters. It is filled with water up to the brim when lead shots, each of which is a sphere of radius. So lead shots, small lead shots are given. That suppose one of them making some big lead shot. So its radius is the given also. That this is the lead shot and its radius is also given. So this is its radius. Okay. So when lead shots, each of which is a sphere of 0.5, are dropped into the vessel, 1/4 of the water flows out. Okay. We will take now. So this radius of the cone is r, and its height we are taking as h, suppose. And actually, we should take this one big. Because there are two radii. So this radius, we will take a small r. This is small r radius. And radius of the cone is capital R. And okay, take height also capital R. Here, small r, capital R. Capital R is given as radius of the cone, 5 centimeter, and height of the cone h is 8 centimeters. Okay. And radius of the lead shot, small r, is given as 0.5 centimeters. So it is filled with water. When these lead shots are dropped into it, so some water flows out. Some water flows out. How many? Find the number of lead shots. So 1/4 of the water. How much water? 1/4 of this volume flows out. So that means, suppose that we are putting n lead shots into the lead, small n, we can take, let n be the number of lead, number of lead shots. Let's write in short. Number of lead shots put in the inverted cone so that the water flows out. How much water flows out? 1/4 of its volume. So that will be equal to the number of volume of n lead shots. So we can say that n into n, when you will multiply with the volume of one lead shot, volume of one lead shot this will be equal to, because how much, that is the law, that is called law of Archimedes principle. When we are putting lead shots, so what will be, whatever will be the volume of the lead shots, that volume comes out. So that's why the volume n into volume of the lead shots will be equal to 1/4 of the volume, because 1/4 of the volume comes out, it is given. It is equal to 1/4 into volume of cone, volume of this cone, 1/4 volume of. Okay. And now you know that volume of that short means sphere. Volume of sphere is 4/3 n into 4/3 pi r cube, and r, small r, is the radius of this red short. So 1 by 4/3 pi r cube is equal to 1/4 into volume of cone is 1/3 pi r square h. So pi r, here we are taking capital R, pi r square and capital H. Okay. When both sides are pi, we can cancel this pi with this pi. And this 3 can be cancelled with this 3. Therefore, we have only n into 4 into r cube. And what is r? R is equal to 0.5. So 0.5 into 0.5 into 0.5 is equal to 1/4, 1/4 r square. Capital R is 5, 5 into 5, 5 into 5 into height. Height is 8 centimeters. Here you can cancel 4 ones are 4 and 4 twos are 8. 5 5 are 25, twos are 50. And 5.5 means zero point 0.5 means 1/2, because when you remove the 5.5 upon 10, 5 ones are 5, 5 twos are 10. So 1.5 means we can write 1/2, 1/2, 1/2 is equal to this one is above 5 5 is 25 into 2, and this 2 twos are 4, and this will cancel with 4, and n will be equal to 25 twos are 50, and this 2 denominators 2 will come right inside. 50 twos are 100. So we got the 100 number of head shots are required so that 1/4 of the water flows out. Therefore, number of head shots required is equal to 100. Okay. Next question is, a solid iron pole consists of a cylinder of height 220 centimeters and base diameter 24 centimeters. So there is a cylinder. This is cylinder. Okay. So cylinder of height and base are given, which is surmounted by another cylinder of height. Height is different, radius is different. Main thing is the cylinder which is surmounted on this cylinder is having radius 8 centimeter, although its radius is 12 centimeter. So there will be small cylinder on it is placed. Surmounted in that means it is kept on the top of the cylinder. There is a small cylinder. There is a small cylinder like this kept on the top of this one. Okay, so these are the two given cylinders, and radius of this big one, its radius is given. Okay, and its height is given 220 centimeters. This height is given. Okay, and radius of this above cylinder and below cylinder. So we will first give it the diagram. Here, radius of this one. This one radius. Let us take this radius. We have given this radius, huh? And this radius capital R. This we will take capital R radius of the bigger cylinder, H capital height of the cylinder, and this small cylinder. Let us suppose that it has height small h and its radius is small r. Here, instead of asking the volume, they ask the mass of the pole. And you know the density is equal to mass upon volume. So its density is also given. This is centimeter cube. Huh? Is what? 1 cubic centimeter. Iron has approximately 8 gram mass. Directly given, no need of that density, because 1 cubic centimeter is 8 gram mass. So how much it will have? So we have to find the mass. For finding mass, we will find the volume of these both cylinders and add them and multiply it with 8. We will get the number of grams. Right here, what is given here? Capital H, height of the bigger cylinder. Capital H is given as 220 centimeters. 220 centimeters, and radius of the base of this cylinder. Just check diameter is given, so half of it 12 centimeters is the radius of this bigger one cylinder. And the smaller ones are mounted on it as height small h 60 centimeters, 60 centimeters, and radius is 8 centimeters. Okay. Find the mass of the pole. The pole, the volume of this solid iron pole. You have to find the volume of solid iron pole. This will be equal to the volume of the small cylindrical portion, volume of the bigger cylindrical portion, or we can say volume of a small cylinder and volume of big cylinder. The volume of small cylinder, volume of small cylinder plus volume of this big cylinder. So volume of cylinder is pi r square h. So small one will be equal to pi r square h, and for big one you will use pi r square capital H. Here pi is given. This is what this is pi. This is pi. Pi is equal to given as 3.14. When pi is given 3.14, we have to use 3.14. That means the answer is coming in decimal. So pi we are taking common first. R square, small r, 8 into 8 into height of the cylinder is 60. Everything is given in centimeter. Okay. Plus r square, capital R square, that is 12 into 12 into height 120 centimeters. Okay. Pi, the value of pi 3.14, then 8 it's 64 to 60 plus 12 into 12 144 into 220. This 3.14 you can multiply inside or you can use solve inside bracket and then multiply same thing. So I am multiplying 3.14 inside. So 3.14 into 144 into 220. So this multiplication will be equal to, when you multiply 9, 9, 4, 7, 5.2 plus 12057.6, and this will be equal to 111532.8 cubic centimeter. This is the total volume of this iron pole. Now we have to find mass of the pole. So 1 cubic centimeter multiplied by 8, mass of this pole will be equal to 111532.8, 1,11,532 multiply with 8, because here it is given the question. You see here is given here. See there, 1 cubic centimeter of iron approximately 8 grams. So this much cubic centimeter will be multiplied with 8 to get the total mass in grams. This is gram, so 8 gram. When 8 gram multiply with this one, we get the answer, or we can convert into, first multiply with 8 and convert into kilogram. So your answer I will write directly 892.26 kilogram by dividing 1000. Okay.